Good, good afternoon, everyone. Today we are going to discuss about BSc third year, semester fifth, mineral exploration, elective A, mineral exploration and mineral economics. In previous session, we have discussed about entire syllabus, which was in the semester 5. Okay, third year, semester 5, geology, mineral exploration and mineral economics syllabus. We have discussed in previous session. Now we are going to discuss about mineral exploration 1, unit 2, unit 1 to 3. So today we are going to discuss about unit 1, that is principle and strategies of mineral exploration. Okay. And previously we have discussed about entire syllabus, which was in our semester 5, elective A, that is mineral exploration and mineral economics. So mineral exploration and mineral economics having 4 blocks, about 12 units. And today we are going to discuss only block 1, unit 1. Okay. So in block 1, unit 1, today we'll discuss about the mineral exploration part 1. It has divided into mineral exploration 1 and 2. So today we are going to discuss about mineral exploration 1. Introduction to the mineral exploration. Mineral exploration is the systematic search for mineral deposits through geological, geophysical, and geochemical investigations. So it may have different type of data collection like geological, geophysical, and geochemical investigations. Okay. And basic geological understanding is essential for exploration, and indirect evidence is sought through the various methods. And target areas for explorations are selected using methods like reconnaissance survey and tracking boulders. Okay. The exploration process involves 3 main methods like airborne, ground, and 3-dimensional surveys. Okay. And in 3 ways we are going to discuss, we are going to collect the field data, airborne field data and ground field data and the 3-dimensional data. Okay. That is quantity, quality, and the expansion of the deposit. Okay. Or dimensions of the deposit. Basic exploration principles are: mineral exploration can be compared to shooting at target where the ore body is concealed. Okay. And here two methods are there. One is prospecting and second one is exploration. In prospecting is the choosing suitable mineral targets for exploration, and whereas in exploration, proving the targets identified during prospecting. These are the main basic principles of the exploration. Okay. And exploration involves eliminating areas of poor potential. Yes. Using available literature from geological surveys and reports and maps. Okay. So in the basic exploration principles, 2 are there. One is prospecting and exploration. In prospecting, is a choosing suitable minerals targets for exploration, and exploration proving the targets identified during prospecting. In this exploration and prospecting, the exploration involves eliminating areas of poor potential using available literature from geological surveys and reports and available primary maps, okay, or literature of the that particular ore body located area. Next, the first we'll go for the in mineral exploration or prospecting. First, we'll go for the reconnaissance survey and direct field evidence. So, primary survey and direct field evidence. We'll go for the field work or field data collection. Okay. A rapid reconnaissance is undertaken to examine natural or man-made rock exposures like river beds, road cuttings, and stream beds. So in the river beds, road cuttings, and stream beds, we are going to collect the rapid Nicanor survey or sample collection. In the direct field evidence includes indirect field evidence. It includes the float or topography of the ore located area, stratigraphy of the particular area, lithology of the area, surface, structure, alteration holes, and old workings and smelting smelting activities. 1 minute. To examine natural or man-made rock exposures like river beds, road cuttings, and stream beds. And direct field evidence includes float ore and topography, stratigraphy, lithology, and contact surface, structure, alteration holes, and old working and smelting activities. So these data we are going to collect. These data we are going to collect in the direct field or direct field data collection process. Okay. Next, after the reconnaissance and direct field evidence or direct field data collection of the particular ore deposited area. Next, we'll go for the methods of prospecting and exploration. So what are the prospecting and what are the exploration methods? We are going to decide based on the primary data or primary field data collected from the ore deposit location or ore deposited area. In these, in prospecting and exploration, we have divided into three types. Majorly, it has divided into three types. One is airborne methods, and the second one is ground methods. Okay, and third one is the three-dimensional methods. Okay, in airborne method, remote sensing, photogeological studies, and aerial geophysical methods. Okay, and in ground methods, detailed geological mapping, scout drilling, and three-dimensional sampling. Okay, and whereas in three-dimensional methods, it involves extensive mapping, trenching, drilling, and exploratory mining to determine the deposit size and grade. So after primary survey or reconnaissance survey or first field visit, we are going to decide methods for the prospecting and exploration. It has divided into three: airborne methods, ground methods, and three-dimensional methods. In airborne method, normally we'll use remote sensing data, photogeological studies, and aerial geophysical methods. Whereas in ground methods, detailed geological mapping, scout drilling, and three-dimensional sampling. And third one is three-dimensional methods. It involves extensive mapping, trenching, drilling, and exploratory mining to determine the deposit size and grade. Okay, with the three-dimensional methods only, we are going to decide how much area it is and what is the depth, what is the quantity of the ore deposit, and what is the size and grade of the ore deposit. We are going to decide based on the three-dimensional data collection or three-dimensional with the three-dimensional methods. Next, in airborne methods, as we discussed in the previous slide, remote sensing, photogeological studies, and aerial geophysical methods. So in airborne method, remote sensing. Remote sensing uses electromagnetic energy reflectivity of objects to gather data. In remote sensing, uses electromagnetic energy reflectivity of objects to gather data, like provides large area coverage and repetitive observations. Repetitive observations. With remote sensing data collection or remote sense airborne methods, we can collect or provide large area coverage and repetitive observations. Whereas in photogeological study, aerial photos and stereoscopic analysis to study geomorphological structures of the ore deposited area. So with remote sensing, large area we can cover and repetitively we can observe or repetitively we collect the data. And in photogeological studies, aerial photos, stereoscopic analysis to study the geomorphological features. Whereas in airborne geophysical methods, we are going to discuss remote sensing, photogeological study, and airborne geophysics methods. In geophysics methods, it includes the measurement of physical properties like gravity, magnetism, and electrical conductivity. Based on these three properties, we are going to collect the geophysical data of the particular ore deposited area. So majorly the prospecting exploration methods are, I'll repeat again. Okay, in basic exploration principles, as divided to prospecting and exploration. Okay, prospecting and exploration are divided in one method, ground method, a three-dimensional method. In airborne method, remote sensing, photogeological study, and geophysical methods. So in remote sensing, we can collect a larger area and we can cover the larger area and repetitively we can collect the data of the particular area. And photogeological studies like aerial photos, stereographic studies, and geomorphological features we can observe. Whereas in geophysics methods like based on gravity, magnetism, electrical conductivity properties, particular ore body, physical properties data we can collect. So gravity, magnetism, and electrical conductors are the physical properties of the particular area which was used in the airborne geophysical methods. So in ground exploration methods, it has divided into airborne methods, ground methods, and three-dimensional methods. Now we'll discuss about the ground exploration methods. Okay, ground exploration method. In ground exploration methods, regional geological mapping will collect and geochemical sampling will do, geobotanical sampling. If any necessary data we can collect or geophysical methods. Okay. So in ground exploration methods, mapping of the minerals bearing areas at a scales like 1 is to 25,000 or 1 is to 2,50,000, we can uh, prepare the mineral bearing area. Okay, area maps. So in regional geology, normally we'll use the 1 is to 25,000 or 1 is to 2,50,000 scaling maps. Okay. In geochemical sampling, the analyzes the metal content in soil, rock, water, and stream sediments. So in geochemical, what we'll do? It analyzes the metal content in soil, rock, water, and the stream sediments to locate mineralization. Okay. And whereas in geobotanical sampling involves plant species analysis to detect mineral enrichment in soil. Involves plant species analysis to detect mineral enrichment in soil. So whereas in geophysical methods, in ground exploration methods, so measures the properties like again gravity, magnetism, and electrical conductivity to identify hidden deposits. Okay. Again, we will use geophysical methods for ground exploration methods also. So they're based on major properties, gravity, magnetism, and electrical conductivity. We are going to identify the hidden deposits of the particular interested area. Okay. So we have discussed airborne methods, that is remote sensing, photogeological study, airborne geophysical methods. In ground exploration methods, regional geological mapping, up to the only 1 is to 2 lakhs 50,000 scale or 1 is to 25,000 scale maps, and geochemical sampling of the metal content in the soil, rock, water, and stream sediments, and geobotanical sampling of the plant species which are present in the particular interested area. And geophysical, again, we'll go for the geophysical methods based on the major properties or major physical properties of the particular area like gravity, magnetism, and electrical conductivity of the area. Okay, next. So airborne we have completed, ground methods we have completed. Next, three-dimensional methods. Three-dimensional methods, ground sampling, soil sampling. Okay. Yes. So in detail, we have data here. The types of ground sampling. Types of ground sampling. In that, soil sample is there, stream sediment sampling, water sampling, rock sampling. So in ground sample, we'll collect the soil sample, okay, sediment sample, water sample, and rock. Chips or rock samples will collect. In soil sampling, used in tropical and temperate regions to identify mineral particles in residual soils. Okay. And whereas in stream sediment sampling, widely used to detect metal matter in stream channels or floodplains. Whereas in water sampling, it is useful in uranium exploration and some causes of copper, some cases of copper and zinc. Okay. So in zinc exploration or uranium exploration, the water sample plays the main role. Okay. And rock sample involves collecting samples from visible rock outcrops to analyze mineral content. So these are the four types of ground samplings. One is soil sampling, stream sediment sampling, water sampling, and rock sampling. In geophysical methods, gravity method, magnetic method, okay, and electrical methods, seismic methods, radiometric methods, we'll discuss. Gravity methods detects gravity anomalies caused by massive ore bodies like iron or chromite. So in gravity method, normally we use for iron or chromite deposits exploration. And in gravity method, it detects gravity anomalies caused by the massive ore bodies of iron or chromite. And magnetic method identifies minerals with magnetic properties like magnetite and pyrrhotite. Pyrrhotite and magnetite, these ore deposits exploration, the magnetic methods normally we will use to identify the magnetite and pyrrhotite mineral exploration with magnetic properties. Whereas in electrical methods, measures conductivity and resistivity of rock for metallic minerals. Normally in identification of the metallic minerals, we'll go for the geophysical methods, which works based on the conductivity property. Normally electrical methods are works on conductivity and resistivity properties of the particular metal or rocks. So it measures the conductivity and resistivity of rocks from metallic minerals. And whereas in seismic method, it uses to artificial earthquakes to study rock layers, ability to transmit seismic waves. And in seismic methods, we are going to identify the ability of transmit seismic waves and study of rock layers by using the artificial earthquakes or creating artificial earthquakes. We'll do the seismic methods and we will collect the we collect the rock layers data and ability of transmit seismic waves in particular area. Whereas in radiometric method, it measures radiation levels from radioactive minerals like uranium and thorium. Particularly in the uranium and thorium deposits or in uranium thorium explorations, radiometric methods are used, and these radiometric methods measures the radiation levels from radioactive minerals like uranium and thorium. So normally uranium and thorium minerals radiations, uh, it produces the radiation. So we'll collect the radiation levels from radioactive minerals. So these are the 5 type of methods involved in the geophysical methods. One is gravity, second magnetic, electrical, seismic, and radiometric method. And whereas in three-dimensional sampling, the final stage of exploration to establish and this is the final stage of exploration. In the three-dimensional sampling, the final is the final stage of exploration to establish the size, shape, and grade of deposit, and it involves detailed geological mapping, involves detailed geophysical mapping, and trenching, drilling, and exploratory mining. So, and then the goal is to obtain data on the deposits, dimensions, and grade in all directions. Okay, so in three-dimensional sampling, and it is the final stage of exploration to establish the size, shape, and grade of the deposit. And it involves a detailed geological mapping, trenching, drilling, and exploratory mining. The goal is to obtain data on the deposit's dimensions and grade in all directions. Okay. And exploration strategies. These are the prospecting strategies. Okay. These are the now. Just I will recollect and repeat again. So this is the introduction to the mineralogy and mineral exploration. And these are the basic principles of the mineral exploration. One is prospecting. Second one is exploration. In prospecting, the methods prospecting and in prospecting and exploration, three type of major methods are there. One is airborne, ground methods, and three-dimensional methods. In airborne methods, remote sensing, geological study, airborne geophysicals. In ground exploration methods, regional geological mapping, geochemical sampling, geobotanical sampling, geophysical methods. Okay. And type of ground sampling, soil sampling, stream sediment sampling, water sampling, rock sampling. Whereas in geophysical, 5 different type of methods are there based on their physical properties. One is gravity method, magnetic method, electrical method, seismic method, and radiometric method. And in three-dimensional sampling, the final stage of exploration to establish the size, shape, and grade of a deposit. It involves the detailed geological mapping, trenching, drilling, and exploratory mining. The goal is to obtain data on the deposit's dimensions and grade in all directions. Exploration strategies. Now two deposits are, these are comes under prospecting. These all are comes under the prospecting methods. Whereas exploration strategies, those are the prospecting. Till up to this, we have discussed prospecting. Now we are going to discuss about exploration strategies. Now two deposits are identical, so exploration strategies must be customized. A checklist of preliminary observations is essential for planning exploration, like area status of the area, and developed or undeveloped. Okay. And topography of the area, plain, hilly, or mountainous. And regional geology of the area is igneous, sedimentary, or metamorphic rock. And size like length, width, and depth of the ore body. And mineralogy and structure of the deposit. So, what is the mineralogy of the ore body and structure of the ore deposit? These are the exploration strategies steps. And key factors influencing exploration method choice, capacity, that is ability to provide reliable samples, efficiency, operational efficiency considering geological and mineralogical conditions, cost, the exploration budget and feasibility, speed, maintaining the required pace of exploration, conformity with the deposit characteristics. In this, matching methods to the deposit type and topography, accessibility and ground conditions of the area, and marketability, the potential for marketable ore during exploration. And whereas in ground methods, crucial for defining the physical and chemical nature of deposit. Whereas in geochemical and geophysical techniques, it helps in pinpointing potential mineralized areas or mineralized zones. Okay. And three-dimensional sampling, the final step to accurately define deposit size and grade. Airborne methods provide broad coverage for initial exploration and exploration strategy adapted to specific geological and geographical conditions with methods selected based on the deposit's characteristics. Okay, whereas in so these are the summary and till now we have discussed BSc third year semester 5th Geology elective A mineral exploration mineral economics. So previously we have discussed entire syllabus which was in the 5th semester Geology elective A, that is mineral exploration and mineral economics. Today we have discussed about Black 1 Unit 1 principles strategies of mineral exploration. Okay. Yeah, in this, we have discussed introduction of the mineral exploration, basic exploration principles like prospecting and exploration, and reconnaissance survey and direct field evidence or direct field data collections like float or topography of the area, stratigraphy of the area, lithology, contact surface, structure, alteration holes, and old working and smelting activities, if any. And methods of prospecting and exploration we have discussed like airborne methods, ground methods, three-dimensional methods. In airborne methods, we have discussed the remote sensing, photogeological study, airborne geophysical methods. And whereas in ground exploration methods, regional geological mapping preparation, scale up to 1 lakh 20, 1 is to 2 lakhs 50,000 to 1 is to 25,000 scale, and geochemical sampling, geobotanical sampling, geophysical methods, data collection, and types of ground sampling also we have discussed, that is soil sampling, stream sediment sampling, water sampling, rock sampling. And in geophysical methods, we have discussed about gravity, magnetic, electric, seismic, and radiometric methods of the particular interested area, particular ore deposited area. And then we have discussed about three-dimensional sampling and exploration strategies. In three-dimensional sampling, we have discussed the final stage of exploration establishing the size, shape, and grade of the area deposited, and it involves a detailed geological mapping, trenching, drilling, and exploratory mining. The goal is to obtain data on the deposits, dimensions, and grade in all directions. And so those are the prospecting strategies or prospecting methods. So, whereas in exploration strategy, we have discussed about area status, topography, regional geology, size and shape of the ore bodies, length, width, and deposit details, and mineralogy and structure of the ore deposit or ore deposited area or formation. And key factors we have discussed like influencing exploration method choice. Those are capacity, efficiency, cost, speed, conformity with deposit characteristics, topography, marketability. These are the main key factors of the exploration methods. So we have discussed prospecting methods and exploration methods. So, and summary, overall we have discussed about summary of the exploration one, method one. Okay. Those are ground methods we have discussed. Geochemical and geophysical techniques we have discussed. Three-dimensional sampling and airborne method, exploratory strategies we have discussed. So this is the unit one of the black one of your elective A exploration and mineral economics paper, semester 5th, BSc third year. Okay. I hope you have understood, and we'll meet again in the next class with unit 2 and unit 2 and 3. In next class, tomorrow we are going to cover the unit 2 to 3. Okay. Thank you. Hmm.